Hi, so today we're going to talk about the nature of matter, so a little bit about the basics of chemistry. So atoms are the first thing we're going to talk about, and basically the definition of an atom is the basic unit of matter. The subatomic particles that make up atoms that we're going to talk about are protons, neutrons, and electrons. So here's the subatomic particles of a helium atom. The protons are positive, neutrons are neutral, so they have no charge, and electrons are negative. Protons and neutrons are in the nucleus. Electrons circle around the nucleus. So in helium has 2 protons, 2 neutrons, and 2 electrons. Its atomic number is 2, and its mass number is 4, and we're going to talk about how to calculate those numbers. So protons and neutrons have about the same mass. Protons are positively charged particles. So I think positive for proton, they both start with P. Neutrons carry no charge. I think neutrons like neutral. And strong forces bind protons and neutrons together to form the nucleus, which is at the center of the atom. So the nucleus is made up of protons and neutrons. The electrons, on the other hand, they're negatively charged, and they weigh 1/1840th the mass of a proton. So essentially we say the mass of an electron is virtually 0. So electrons are in constant motion in the space surrounding the nucleus of the atom. So electrons are attracted to the positively charged nucleus, but remain outside of the nucleus because of the energy of their motion. So they're attracted to it, so they're part of the atom, and they're rotating around this nucleus, but they're not stuck to the nucleus. They stay outside the nucleus. So because atoms have equal numbers of electrons and protons, and because these subatomic particles have equal but opposite charges, atoms are said to be neutral. So because we have the same number of electrons, which are negative, same number of protons, which are positive, the atoms are neutral. There's no charge. So we're now going to talk about elements and isotopes. So a chemical element is a pure substance that consists entirely of one type of atom. So elements are represented by a 1 or 2 letter symbol. So example is C stands for carbon and Na stands for sodium. So if you take a look at a block of gold, gold's symbol is Au, and a gold block is made up of entirely gold atoms. So it is a pure element. It's considered an element. So the number of protons in an atom of an element is the element's atomic number. So however many protons there are, that's its atomic number. So you can see the atomic number on a periodic table, and the second you see that atomic number, such as helium is 2, hydrogen is 1, that also gives you the idea of the number of protons. So carbon has 6 protons, so its atomic number is 6. More than 100 elements are known, but only about 24 are commonly found in living organisms. We're going to talk about the most common elements in living things in another section. So isotopes, atoms of the same element that differ in the number of neutrons they contain, are known as isotopes. The sum of the protons and neutrons in the nucleus of an atom is called its mass number. So if we want to determine what the mass of the element is, or the atom, you need to add the number of protons and the number of neutrons. So you have to remember a couple of things. The number of protons is also known as its atomic number. So if we have carbon, and carbon's atomic number is 6, we know we have 6 protons. And remember, the number of protons is equal to the number of neutrons in the nucleus. So 6 plus 6 equals its atomic mass, or mass number. So every time you see the word atomic mass, it's the same as mass number. So isotopes, however, are identified by their mass numbers. So a normal carbon atom would be called carbon-12 because it has 6 protons and 6 neutrons, which makes its mass number 12. So there's 3 isotopes, however, of carbon, and carbon-12 is the most common, but we also have carbon-13 and carbon-14. Each isotope has a different number of neutrons. So that's what makes isotopes different. So in carbon-12, it has 6 neutrons and 6 protons, but in carbon-13, it has 7 neutrons and 6 protons, and in carbon-14, it has 8 neutrons and 6 protons. So because they have the same number of electrons, all isotopes of an element have the same chemical properties. So that means they can bond with the same elements. They melt at the same temperature, etc. So isotopes of carbon, non-radioactive carbon-12, we have 6 protons, 6 electrons, 6 neutrons. But carbon-13 is also non-radioactive. It has 6 electrons, 6 protons, and 7 neutrons. Because remember, the definition of a neutron is that it differs in the number, the definition of an isotope is that it differs in the number of neutrons. And radioactive carbon-14, so isotopes can be radioactive. We'll talk about that in a second. But radioactive carbon-14 has 6 electrons, 6 protons, and 8 neutrons. So radioactive isotopes, some are radioactive, meaning that their nuclei are unstable and break down at a constant rate over time. Radioactive isotopes are used a lot in biology. They're used to determine the ages of rocks and fossils. They're also used to treat cancer. They're used to kill bacteria that cause food to spoil. They're used as labels or tracers to follow the movement of substances within an organism. So one of the professions you can go into is where you're a radioactive isotope tech, where you basically administer the tracers or the radioactive isotopes into the patient. So chemical compounds. In nature, most elements are actually found combined with other elements in compounds. Most are not in their elemental form. Like a block of gold, yes, that is a pure element, but most of the time atoms are found bonded to other atoms. So a chemical compound is a substance formed by the chemical combination of 2 or more elements in definite proportions. So the physical and chemical properties of a compound are different from the elements from which it's formed. So scientists show the composition of compounds by a kind of shorthand known as a chemical formula. So example is water. Water is H2O. It contains 2 atoms of hydrogen for each atom of oxygen. The formula for table salt, NaCl, indicates that a sodium and chlorine combine in a 1-to-1 ratio. So we got to talk about how these chemical compounds form, and they're formed by chemical bonds. The atoms in compounds are held together by chemical bonds, and bond formation involves the electrons that surround the atomic nucleus. The electrons that are available to form bonds are called valence electrons. So the outermost shell of electrons are the ones that are available to form bonds. And in each atom, you want 8 valence electrons, unless you're hydrogen or helium. In that case, you only want 2. But for the most part, you want a full shell of outer electrons, and so you want 8 electrons. So the main types of chemical bonds are ionic bonds and covalent bonds. So for ionic bonds, it's formed when 1 or more electrons are transferred from one atom to another, basically given to the other atom. An atom that loses the electrons has a positive charge. That makes sense because if you're losing a negative charge, you become positive. The atom that gains electrons has a negative charge. That makes sense because if you're gaining a negative charge, you become -1. So these positively and negatively charged atoms are known as ions. So here's an example with the sodium atom and the chlorine atom. There's in sodium 11 protons, 11 electrons. The charge is 0. And in chlorine, 17 and 17, the charge is 0. There is a transfer of 1 electron from the sodium to the chlorine, because remember, you want 8 valence electrons. So you want a full outer shell of electrons. So in this case, sodium has only 1 valence electron, and so it wants to get rid of that so that it has 8 in its other orbital. Whereas chlorine has 7 and it wants an 8th. So it transfers an electron from sodium to chlorine. as shown. So now, after the bond is formed between NaCl, you see there's 11 protons and 10 electrons in sodium, so therefore it has a positive charge of 1. In chlorine, there's 17 protons, 18 electrons, and the charge is -1 because it gained an electron, it gained a negative charge. So for covalent bonds form when electrons are shared, not transferred. So when the atoms share 2 electrons, the bond is a single covalent bond. When they share 4 electrons, it's a double bond. And when atoms share 6 electrons, it's a triple bond. So the structure that results when atoms are joined together by covalent bonds is called a molecule. So molecules are atoms joined together by covalent bonds. A molecule is the smallest unit of most compounds. So a water molecule, each hydrogen atom forms a single covalent bond with the oxygen atom. So hydrogen and oxygen each share 2 electrons. Last, we're going to talk about van der Waals forces. This is not a bond, but it's kind of an attraction between atoms. So when molecules are close together, a slight attraction can develop between the oppositely charged region of nearby molecules. Although van der Waals forces are not as strong as ionic or covalent bonds, they hold molecules together, especially when the molecules are large. So here's an example. Van der Waals forces form between the molecules on the surface of a gecko's foot and the molecules on the surface of the wall, allowing the gecko to walk on the ceiling and walk up walls. The combined strength of all the van der Waals forces allows the gecko to grip the wall. And that is all for today. Thanks for watching.